Hello grade 8s. This is 1.3 measuring line segments. So what we're doing today is trying to figure out how do we measure segments, line segments. Now some of them it's pretty easy, you know, like if this is a 1 centimeter grid paper, which it's not, but let's just pretend it is. 1 centimeter grid paper, we'd have 1 centimeter, 2, 3, 4, and we know that this is 4 centimeters. Now in reality, it's not exactly centimeter, it's quite a bit less. This is actually 2.5 centimeters, maybe a little bit less from one to the next. But what about if we have some lines that, you know, on the grid paper it's a little bit off and we're not quite sure exactly how much it is. Like you could look and you'd be like, okay, well it moves up 2 and it moves over 4. I don't really know, it's got to be a little bit more than 4, but not quite sure. So if we know that this across was 2.5, well, if we look at it again, I bumped my camera, it's actually a little bit more than that. It's 2.7 or 2.8 centimeters. But even using a ruler, there's a little bit of error in that my ruler sometimes doesn't line up perfectly with the ends of the line and that sort of thing. I could have it maybe just a little bit off. It's a little bit too far this way or that way. There's a little variance, as well as on this end, just looking at it, I might not exactly have a point where it is. So what we need to do is, if these points are truly right on these corners, a ruler is not going to help. We need to do a little math. And you know what? We're going to go back to assuming that this is 1 centimeter grid paper, just so it's a little bit easier. Which means from one corner to the next, it's 1 centimeter either across or down. So if I'm trying to make a measurement of this length, what I can do is use what I know where it's moved up 2 and over 4 and use that to construct a square here. So for this line P to Q, I'm going to construct a square that includes that. So here where it goes up 2, instead I'm going to take this measurement, this 4 across, and I'm going to go down 4. And then I'm going to go over 2 to this point right here. And I'm going to connect that line. And I'm going to do the same thing. I'm going to go down 4 and over 2 to that point, and I'm going to connect it. Why is it 4 and 2? Because that's what I was dealing with here. I had 2 and I had 4 across. Okay? And then I'm going to connect those dots. And I know it's a square if then from one point to the other it goes 4 and 2 are my dimensions, or 2 and 4. And I'll call those points R and S just in case I want to refer to them. So now what I'm going to do is I'm going to take my ruler and I'm going to just follow along the line from each of these points going towards the center. Not exactly at the center, but just kind of towards. I'm going to draw a little bit of a dotted line along there. Okay? And I'll take my R as well, point R, and do the same thing, following one of the grid lines that goes through the middle. So this one doesn't, that one doesn't, but this one does. And I'm going to bring it through the middle. Let's draw a dotted line. I'm going to do the same thing for S. I'm going to do the same thing for Q. Right there. And we're going to see that there's a square that showed up here, which I've now highlighted here. There's a square in the middle of this square that had this line P to Q that I'm trying to figure out the length of P and Q. And if I do a little bit of erasing, there's going to always be these 4 triangles around the edge. If I erase these, there's going to be 4 triangles. Do you see these 4 triangles? There's one here, there's one here, there's one here, and there's one here. And I erased all those extra lines kind of going out that I didn't need. Now looking here, we might be able to use something that we know called area. And we know area of a rectangle or a square is simply the base times the height. And we know that area of a triangle is simply base times the height divided by 2. And why is it divided by 2? Because if you took your base and your height and you multiplied, it would be this whole rectangle here. But it's only half of that rectangle, right? This is one half of it and this is another half. So we would be talking about this right here, which is half of what the base times the height is. So that's grade 7 math you would have learned last year. So looking at this, we have 4 triangles that have a base of 4 and a height of 2, or a base of 4 and a height of 2, a base of 4, a height of 2, a base of 4 and a height of 2. We've got 4 triangles. I'm just going to number them. We've also got one square in here, which I'll just call 5, which is 2 by 2. So that means that the area of all of this will be this area plus this area plus this area plus this area plus this area would be what this is made up of, right? It's kind of like pieces of a chocolate bar. If you have, this is a weird shaped chocolate bar, but if you had 5 pieces of this chocolate bar, the whole chocolate bar would be this space, right? This area. So looking at the area of this shape, so the area of, let's just shift this over a little bit. The area of PQRS, which we don't really need to write that in, I'm just using some more reference. We're talking about this whole area. Well, it's going to be this area of this rectangle in the middle, right? So if this is a centimeter, that's 2 centimeters. What's the base? It's 2 centimeters. So it's going to be 2 centimeters times 2 centimeters. And we'll write centimeters in. Don't forget my units. And then we've got 4 triangles, right? So we're going to add that to it, right? We have the area here, and we're going to add it to these areas where there's 4 of those triangles. And each triangle's area is a base times height. Each is a base times height divided by 2, which is base is 4, height is 2. 4 centimeters times 2 centimeters, all divided by 2. Or, if you want to write down a lot of things over and over and over and over and over, you could write this over and over, just 2 times 4 for this part 5, plus the area of 1, plus the area of 2, plus the area of 3, plus the area of 4, which would be the same calculation over and over. But remember, multiplication is repeated addition. And I'll just show where this math's coming from a little further. It looks pretty complicated, and that's why I skipped some steps. But remember, the area of this whole thing is simply just the area of the sum of its parts, right? Adding all up the parts. So the area of the rectangle or square plus the area of each of the triangles is what that whole area would be. So if we put in those formulas, the area of the square was base times height. This is a different base and height than these ones. Typically you'd use different variables, but that's okay. Plus the area of 4, which is a triangle, we'd have to go base times height divided by 2, and area 3 is also a triangle, area 2 is a triangle, and area 1 is a triangle. So we use that triangle formula. But we have this same thing over and over, which these are the same variables. So repeated addition, remember, is multiplication. How many times is it here? It's 4. So we're going to take 4 and multiply it by that, which is why we got our base height 4 base height divided by 2. So if we do the math here, area of PQRS equals, well, we have 2 times 2, which is 4 centimeters squared, plus, let's leave this for a bit, 4 times 2 is 8, and then divided by 2 is 4. But it's 4 centimeters times centimeters, so that means it's centimeters squared. And to keep doing some more steps here, area of PQRS, that shape, it would be 4 centimeters still squared, plus 4 times 4 is 16 centimeters squared. So area of PQRS is 4 plus 16, it's 20 centimeters squared. But remember, I wasn't just telling you to find out the area of this. I actually wanted to find what? The length of P to Q, sorry, I almost put R, that line from P to Q. That's what we were trying to find. We were trying to find this length. So let's look at this shape. This is our one side, right? So this is our new base. This is our new height, which happens to be the same. So these are the same. And since B equals H, then technically this is also B. It's the same length, right? And our area of a square is simply these two multiplied by each other. So this area of the square is the same thing as this. So 20 centimeters squared happens to be the same thing as our bases times our base, which happens to be, remember 20 centimeters squared happens to be base squared. I accidentally flipped side. I'm going to step back. Not sure why I flipped sides there. I didn't mean to. 20 centimeters squared, that is the same thing as our base times our base, right? These two here, which happens to be the same thing as base squared. And remember, this is a different base than the bases we were using at the top. We have 20 centimeters squared. And how do we get rid of square to figure out what this length is? We square root it. So we square root that. And remember, these cancel out. That's what we learned last lesson. So we're left with base equals the square root of 20. And centimeters squared, the squared cancels out with that, and we're left with the square root of 20 centimeters. And that's actually our answer. That's the most specific that we can get. With a calculator, you could do a square root of 20, and you could get a number with a bunch of decimals. It'd be somewhere between, well, if 4 times 4 is 16, and 5 times 5 is 25, it'd be somewhere between 4 and 5. This would be 4 decimal something, right? It would be approximately 4 decimal, I'm not sure what it is. So that means that this length from P to Q is the square root of 20 centimeters. So would this over here. I'm going to show you another way. It's very similar, but there are some differences. What if we were to try to find the length from A to B? Now, looking at this, it's not along one of my grid lines, so I wouldn't be able to figure it out with these centimeter squares. But there's something that we can do. We're going to make a square again, and it could be that we notice that it's 1 up and 2 over. So that means we're going to go 1 over and 2 down to make it so that this is a right angle. Then we're going to go 1 down, 2 over, and then we'll connect all of these. We'll make a square. Now, instead of our last example where we drew towards the middle, what we can also do is just take the grid line along the side that just passes by and just draw. And on each of these, draw straight across. And this one, and the final one. And what we'll see here is that we've now made, there's a shape in the middle, there's this one rectangle, and then we've also got 4 triangles around the outside. So there's 1 plus 4 more, that's why it's 5. And with this, we could figure out the area of these triangles, right? So we have a 2 by 1. So our base is 2, our height is 1. And that's the same thing for all of these. Height is 1, base is 2. Height is 1, base is 2. Height is 1, base is 2. So we've got 4 of those. And then we can also figure out the area of this outside rectangle that I've made, also known as a square, which is 1, 2, 3. And 1, 2, 3. So using what we learned on our last question, we can do something very similar, except it's going to involve subtraction instead. The area of this shape here, ABCD, is going to be equal to the area of, let's call it EFGH. It's going to be the area of that outside rectangle subtract these parts, right? So if we take this area and we chop off these pieces out here, we'd be left with this area on the inside. So it's going to be subtract the triangle areas. So the 4 areas of triangles, I'm going to call it. Right? Because if we had a chocolate bar this big and we chopped off these pieces, what would we be left with? This much, and that's the area that we're trying to figure out. Why? Because with that area we can figure out our sides. A and B is the one we're looking for. So, use our formulas. We know that the area of ABCD is going to be the area of this EFGH, which we know our base and height are 3. So it's going to be 3 centimeters times 3 centimeters. And then we're going to subtract 4 times the area of these triangles, which the area of the triangle is height is 1, base is 2, all divided by 2. So height is 1 centimeter times 2 centimeters, all divided by 2. And because I have brackets within brackets, I'm going to make these square brackets. If you use round, it's fine. And then we'll do some math here. A, B, C, D. I heard about someone with the name Absidy, and that's how it's spelled. It's a modern sounding name. 3 times 3 is 9, and centimeters times centimeters is centimeters squared. Subtract 4 times 1 times 2 is 2. Divided by 2 is back to 1. And it's centimeters being multiplied, centimeters squared. And so then this becomes subtract 4 centimeters. So 9 centimeters squared, subtract 4 times 1 is 4 centimeters squared. ABCD, area of ABCD. So the area of ABCD is finally equal to 9 centimeters squared, subtract 4 centimeters, 9 subtract 4 is 5 centimeters squared. So with adding and subtracting, we have to make sure the units are the same, and then it just stays the same units when we add or subtract. But it's not just the area of this shape that we were trying to figure out. It was the length of this side, which we know that this times this will give us the area. So we know that this area, which we figured out is 5 centimeters here, it's the same thing as some number times itself, right? It's this AB length times itself, which we also know as squaring it, right? So AB squared is going to be 5 centimeters squared. And how do we get rid of a squared? We square root it. So what is the length of AB? It is the square root of 5 centimeters squared. Sorry, centimeters. Because I square rooted, the unit then becomes centimeters. And using our chart, we know that that length is going to be somewhere between 2 and 3. Why? Because the 5 here that would get square rooted is kind of between 4 and 9. So I'd expect a 2 decimal and a lower number in the decimals.